Hi guys, in this video I'm going to be talking about the quantitative theory of money, inflation, and interest rates. There are three important things to talk about before we move on. Number one is the money supply, which is the total value of money available in the economy. The second thing is the price level, which is a general measure of overall prices for goods and services in the economy. And lastly, we have the velocity of money, which is the amount of times that $1 is used to purchase goods and services within a year in the economy. So now that we know these terms, we can move on to the quantity equation, which states that the money supply times the velocity of money is equivalent to price level times the real GDP. Price level times real GDP could also be simplified to nominal GDP. So why do we need to know the quantity equation? Well, we can use mathematical approximation to convert it into growth rates. Once we do that, we see that the change in money supply plus the change in velocity of money is equivalent to the change in price level plus the change in the real GDP. So Fisher assumed that the velocity of money was constant. So if the velocity of money is constant, the change in velocity of money is zero. Therefore, we can cross it off the equation. And we also know that the change in price level is equivalent to inflation. Therefore, we can just rearrange the formula to get the inflation rate, which is equivalent to the change in the money supply minus the change in real GDP. So what does that formula tells us? We can see that the inflation, which is the rise in overall prices, um, happens when the money supply grows faster than the real GDP. So in the equation, we can see that if the money supply grows faster than the real GDP, we get inflation. We also have the Fisher effect, which says that the nominal interest rate is dependent on the expected future inflation rate. In the formula, we can also see that, so we have the nominal interest rate is equivalent to real interest rate plus the expected inflation rate. Um, Therefore, we can see that the nominal interest rate is dependent on our expected inflation rate. Also notice that the expected inflation rate calculated in the previous formula. So now that we know both of these concepts, we can solve more complex problems. In this example, it states that the money supply increases by 15%, the real GDP increases by 6%, and the real interest rate is 7%. We want to know the nominal interest rate. In this question, we're assuming that the velocity of money is constant, but be careful because some questions might say that the velocity of money is changing. Therefore, you can't assume that that is zero. The change in velocity of money is zero and cross it off the equation. You also have to add it into your equation. But in this case, it's constant, so we're just gonna assume that the change in velocity of money is zero and take it off our equation. So the first step to solving this problem, we want to write out all our variables and see what we need to solve. So the change in money supply, we have that, which is which is an increase of 15%. And the real GDP, we also have that it increases by 6%. We also have the real interest rate, which is 7%, and we want to find the expected inflation rate and the nominal interest rate. So in step two, we can use a formula that we discussed earlier to find the expected inflation rate, which is the change in money supply minus the change in real GDP. So we already have those numbers. It's 15% minus 6%, which is 9%. So 9% is the expected inflation rate. Lastly, in our third step, we have that the we can use the second formula, the Fisher formula, which says that the nominal interest rate is equivalent to real interest rate plus the expected inflation rate. So the real interest rate, we know that is 7%, and we add 9%, which is our expected inflation rate, and we get 16%. And in our last step, we just want to make it more organized, so we say that the nominal interest rate is 16%. That is the end of my presentation. Thank you for listening, and this is my citations.